We still can't be completely sure. Is 3I Atlas just a comet, or could it be something else entirely? That question is about to get a lot more interesting. Right now, at this very moment, something unprecedented is happening in space, and what unfolds in the next few weeks could change everything we thought we knew. Good morning. Today we're bringing you breaking developments on the interstellar visitor 3I Atlas that are unfolding as we speak. And I need to tell you, what's happening right now has never been done before in the history of space exploration. Let me start with what's happening today, November 3rd, 2025, right now. The ancient interstellar comet 3I Atlas is making its closest approach to Venus, passing within just 60 million miles of our sister planet. But that's not the extraordinary part. The extraordinary part is what happened during the past week and what might happen in the coming days. Here's what we know. Between October 30th and November 6th, NASA's Europa Clipper spacecraft is currently flying directly through the ion tail of this interstellar visitor. Yes, you heard that right. A spacecraft built to explore Jupiter's moons is currently inside the plasma trail of an object from another star system. This has never happened before, ever. But let's back up for a second, because there's a lot more to this story, and some of it is controversial. Very controversial. Harvard astrophysicist Avi Loeb has been making bold statements about 3I Atlas. He's suggesting this might not be a natural comet at all. He's talking about motherships. He's talking about mini-probes. He's asking whether this object might release surveillance devices toward Earth when it makes its closest approach on December 19th, just 6 days before Christmas. Now, before you dismiss this, let me be clear. Loeb is not some conspiracy theorist. He's the former chair of Harvard's astronomy department. He's a respected scientist. But his theories about 3I Atlas have divided the scientific community right down the middle. So what's really going on? Let's break down everything that's happening piece by piece. First, the Europa Clipper situation. NASA's Europa Clipper spacecraft launched recently and is currently on its way to Jupiter. The spacecraft's trajectory was calculated years ago. Nobody could have predicted that it would pass directly through the ion tail of an interstellar comet. But that's exactly what's happening right now. An ion tail is different from the dust tail you might see in pictures of comets. It's made of charged particles, plasma stripped away from the comet by solar wind. These ion tails can extend for millions of miles behind a comet, creating invisible highways of charged particles through space. Europa Clipper has instruments designed to detect and measure these particles. Its plasma sensors, magnetic field detectors, and particle analyzers are all capable of picking up the signature of an interstellar comet's ion tail. The question is, did NASA's team manage to activate these instruments during the passage? Did they capture data? We don't know yet. NASA hasn't released any information about this. And remember, due to the government shutdown that started October 1st, NASA's been restricted in what it can share publicly. But the data exists. Somewhere in NASA's computers, there's information about what Europa Clipper detected as it flew through that ion tail. This would be the first time ever that a spacecraft has directly sampled material from a confirmed interstellar object. Not observed from a distance. Not photographed, actually flown through it, tasted it, measured it. And Europa Clipper wasn't alone. ESA's Hera spacecraft, which is on its way to study the aftermath of the DART asteroid impact mission, also potentially passed through the ion tail between October 25th and November 1st. That means we might have 2 spacecraft that sampled this interstellar material. Think about what this means. These particles, these molecules, these atoms floating in that ion tail, they didn't form in our solar system. They formed around another star, possibly 7 billion years ago. They've been traveling through the vast emptiness of interstellar space for longer than Earth has existed. And now, 2 of our spacecraft have flown directly through them. The data could tell us about the chemistry of that distant star system. It could reveal whether the conditions there were similar to our own solar system. It could provide clues about planetary formation in other parts of the galaxy. This is huge. But let's move to today's event, the Venus flyby. Right now, 3I Atlas is passing within 60 million miles of Venus. That's closer than Mars was on October 3rd when we got those incredible images from the Mars orbiters. But here's the problem. We don't have any spacecraft at Venus right now capable of observing the comet. NASA's Veritas and Da Vinci missions to Venus haven't launched yet. ESA's Envision won't arrive until the 2030s. The only spacecraft currently at Venus is Japan's Akatsuki orbiter, and it was just declared dead. Its fuel has run out, and it's no longer operational, so we're missing this opportunity. Venus is the second planet from the Sun, roughly Earth's twin in size. Having an interstellar visitor pass this close to Venus is incredibly rare. We could have used this chance to observe how the comet interacts with Venus's thick atmosphere, its intense greenhouse effect, its unusual rotation. But we're not completely in the dark. Ground-based observatories might catch a glimpse. The comet is currently in Virgo constellation, near the bright star Spica. Professional astronomers with large telescopes can still track it, even though it's relatively close to the Sun in our sky. And here's where things get really interesting. In just 8 days, on November 11th, 3I Atlas will return to visibility in the morning sky for amateur astronomers. After being hidden behind the Sun for more than a month, it's finally emerging from solar conjunction. Sky and Telescope magazine reports that by November 11th, the comet should reach about 10 degrees altitude before dawn for observers at mid-northern latitudes. You'll need at least an 8-inch telescope to see it, but it should be visible. Current predictions put it around magnitude 10 to 11, which is within reach of serious amateur astronomers. The magazine also notes something intriguing. The comet might be brighter than originally expected. There's been some evidence of increased activity, possibly from the recent perihelion heating. If that surge continues, smaller telescopes might be able to capture this interstellar wanderer. Between November 15th and 16th, the comet will pass within half a degree of the galaxy NGC 4691, creating a photogenic opportunity for astrophotographers. Then, from November 16th through early December, the moon will be out of the way during prime viewing hours, offering dark skies for observation. By December 7th and 8th, 3I Atlas will cross into the constellation Leo. On December 27th, it will pass just 1.8 degrees south of Regulus, Leo's brightest star. These are the guideposts amateur astronomers can use to track this visitor. But now we need to address the elephant in the room, Avi Loeb's claims. Loeb has published papers and given multiple interviews suggesting that 3I Atlas might not be natural. His reasoning? Several factors. First, the trajectory. 3I Atlas's orbital plane is tilted just 5 degrees from the ecliptic, the plane where all our planets orbit. The probability of a random interstellar object having this alignment is less than 0.2%. It's passing remarkably close to Venus, Mars, and Jupiter, with a combined probability of less than 0.05%. Second, the size and mass. 3I Atlas is estimated to be 1,000 times more massive than the previous interstellar visitor, 2I Borisov, and perhaps 1,000,000 times more massive than Oumuamua. Why would the third interstellar object we discovered be so much larger than the first two? Third, the nickel abundance. Observations detected atomic nickel vapor at distances from the Sun where metals shouldn't normally vaporize. Loeb suggests this unusual chemistry might indicate artificial materials. Fourth, the timing. The comet reached perihelion on October 29th, passing behind the Sun from Earth's perspective at the optimal moment. Loeb asks, if you were an alien spacecraft wanting to perform a maneuver unobserved, wouldn't this be the perfect time? In his recent appearance on Joe Rogan's podcast, Loeb described 3I Atlas as a potential Trojan horse. It looks like a comet on the outside, but could it be carrying something else on the inside? Could it release mini-probes during perihelion? Could those probes be heading toward Earth right now? Loeb even speculated about the December 19th closest approach to Earth, calling it a potential delivery of Christmas gifts to humanity. Now, he's being provocative here, possibly tongue-in-cheek, but he's raising a serious question. Should we be monitoring for any unusual activity? He's asked the Galileo Project team to watch for anomalous objects in Earth's atmosphere in the coming months. They have 3 Galileo observatories collecting data on unidentified aerial phenomena. If 3i Atlas did release probes, might they show up in that data? Loeb also mentions that when 3i Atlas reaches Jupiter in March 2026, the Juno spacecraft could use its radio antenna to check for any transmissions as a technological signature. He's thinking several moves ahead. Now here's the reality check. The overwhelming majority of astronomers believe 3i Atlas is exactly what it appears to be, a natural comet. And here's why. The James Webb Space Telescope detected clear evidence of cometary outgassing. Carbon dioxide, water vapor, carbon monoxide, carbonyl sulfide. These are all molecules we'd expect from a comet. The comet has a visible coma and tail. It's behaving exactly like a comet should behave. The unusual trajectory? It's rare, but not impossible. We've only discovered 3 interstellar objects. Our sample size is tiny. We can't make statistical judgments based on 3 data points. The large size, bigger objects are easier to detect. We probably missed thousands of smaller interstellar visitors. We're only seeing the big ones that happen to get bright enough. The nickel? Unusual, yes, but comets are chemically diverse. Which Atlas formed in a different stellar environment. Different chemistry is exactly what we'd expect from an interstellar comet. The ExoMars images from the Mars flyby showed a fuzzy white dot behaving exactly as a distant comet should. The coma measurements matched predictions. There's been no evidence of maneuvering, no deviation from gravitational trajectories, no anomalous accelerations beyond what's expected from outgassing. Professor Darrell Seligman from Michigan State, who led early studies of 3i Atlas, stated firmly, "There have been numerous telescopic observations demonstrating that it's displaying classical signatures of cometary activity. NASA and ESA have both officially confirmed this is a comet. Not an asteroid, not a spacecraft, a comet. But here's what makes this story so compelling. We can test these ideas. We have data coming. The Europa Clipper ion tail measurements, the JUICE observations in November, which we'll receive in February 2026. The high-rise images from Mars Reconnaissance Orbiter, whenever NASA finally releases them. December observations from James Webb. Ground-based observations starting November 11th. If 3i Atlas is natural, the data will continue showing cometary behavior all the way out of the solar system. If it's something else, if Loeb is right, we'll see anomalies, unexpected maneuvers, trajectory changes, objects separating from the main body. The December 19th Earth closest approach is particularly interesting. At 168 million miles away, it poses no threat, but it will be close enough for detailed observation. If mini probes were released, if objects separated from the comet, our telescopes would detect them. Colin Wilson from ESA said something important about the recent observations. It's always extra exciting to see our spacecraft responding to unexpected situations like this one. I look forward to seeing what the data reveals following further analysis. That's the key phrase, what the data reveals. Not speculation, not theories, data. Michael Kuepers from ESA's Comet Interceptor mission put it well. Since Comet Interceptor was selected in 2019, 2 more interstellar objects have been discovered, showing large diversity in their appearance. Visiting one could provide a breakthrough in understanding their nature. That's what we need. Not more speculation, but actual missions to these objects. Comet Interceptor will launch in 2029 and wait in orbit for the next interstellar visitor. When it arrives, Comet Interceptor will rapidly deploy and actually fly to it, study it up close, maybe even land on it. That's when we'll truly know what these objects are made of. That's when we'll answer these questions definitively. So where does this leave us? Right now, November 3rd, 2025, we're in a unique moment. 3i Atlas is passing Venus. Europa Clipper is flying through its ion tail. In 8 days, amateur astronomers will start seeing it again. In 6 weeks, it makes its closest approach to Earth. In 4 months, it reaches Jupiter. We have months of observations ahead. We have data being collected by multiple spacecraft. We have the entire astronomical community watching. This is the most observed interstellar object in history. We will learn more about 3 Atlas than we ever learned about Oumuamua or Borisov. Is it a comet? Almost certainly yes. Could it surprise us? Possibly. Will we learn something new about interstellar visitors? Absolutely. The next few weeks are critical. Watch for announcements about the Europa Clipper data. Watch for the HiRISE image release. Starting November 11th, follow amateur astronomer reports as they track this visitor through Virgo, into Leo, past Regulus. And yes, pay attention to December 19th. Not because we expect Christmas gifts from aliens, but because this is our last best chance to study this ancient wanderer before it leaves our solar system forever. This 7-billion-year-old traveler, born around a star that may no longer exist, in a planetary system we'll never see, is giving us a once-in-a-lifetime opportunity to touch something truly alien. Not science fiction alien, real, physical, measurable alien. From outside our solar system. That's what makes this so incredible. Whether it's natural or artificial, whether it's ice and rock or something else entirely, 3i Atlas represents our first real contact with matter from another star system. That alone makes it worth watching, worth studying, worth understanding. So keep your eyes on the sky. Keep watching the news. Keep following the data. Because whatever 3i Atlas turns out to be, we're living through a historic moment in space exploration. And who knows? Maybe Avi Loeb will be vindicated. Maybe we'll see something nobody expected. Or maybe we'll confirm that the universe is full of icy wanderers just like this one, and we're only now learning to see them. Either way, the next chapter of this story is about to begin, and we'll all be watching together.